All right, back at it again here. This is the last way we're going to learn how to solve a system of equations that has two equations in it. This is solving by elimination. Okay, it says you can solve for a letter and get a real number answer when you cannot solve for a letter and get a real number answer when there's more than one variable in the equation. Okay, that's all these situations are helping solve that problem. Elimination takes care of this problem by eliminating one of the variables in the beginning. Okay, so that's hence the name elimination. We're going to be eliminating one of the variables. Okay, in order to do elimination, all right, to do elimination, what you need to have is opposites on one of your variables. So what does opposites mean? Well, the opposite of 2 is -2. The opposite of 8 is -8. The opposite of -20 is +20, okay? So as you can see in these two example problems, we already have opposites on one of the variables. It doesn't matter which variable it's on, okay? That doesn't matter or does not affect the answer or the difficulty at all, but you have to have opposites on one of your variables, okay? Here, we have opposites on our y's. We have -6y, and then in the other equation, we have +6y. So we are set up and ready to do elimination. You cannot start the process of elimination until you have those opposites. Once I have them, we're going to draw a big old long equal sign like I just did. And now, here we go. 5x, I'm going to add these two equations together, okay? And what the opposites is going to do is it's going to cancel those variables out, okay? So 3x plus 5x. Well, why is it plus? Because there's nothing out here. Why is it plus? Well, because the 3x is positive. If the 3x was negative, then we would do minus. But since it's positive, we do 5x plus 3x is, of course, 8x. -6y plus 6y is 0y. I'm not going to write 0y. That's eliminated, hence the name elimination. Bring down my equal sign. -32 plus 48, again, it's plus 48 because the 48 is positive, is 16. And wow, now I just solved this very simple one-step equation for x. So x equals 2. So I know my answer is 2, comma, something. Okay, now, I can now go back. I still need to solve for y. I'm only halfway done. I can now go back to either of the original equations to solve for y. What I'm going to do is I'm just going to plug what I know x is, 2, in for x into either of the equations. It doesn't matter which one you use. You'll get the same correct answer either way. I'm going to choose to use the second equation because it has all positive numbers. So to me, that one looks the easiest. So I have 3 times, whoops. I said times, but I didn't do it. 3. Instead of x, I'm going to plug in what I know x to be, which is 2. 3 times 2 plus 6y equals 48. 3 times 2 is 6 plus 6y equals 48. And now that's a two-step equation, -6. 6y equals 42, divided by 6. And y equals 7. So the x-y combination that makes both of these equations true at the same time is 2, 7. That's also the point where if you graph both of these lines, that's where the point where those two lines would intersect. Now, this is called day 2. These are things I already have created, okay? So don't worry about this. Now, what we get into now is, well, what happens if we don't have opposites yet? Because I have to have opposites. So if we don't yet have opposites, we have to create some. Now, let me give you something that you may or may not know in math, okay? Let's take an equation that we know to be true. For instance, that 3 plus 7 equals 10. I know that equation is true. I can manipulate any true equation using multiplication and multiplication only, because that equation remains true. The values are just bigger. Okay, so if I want to take this true equation and multiply it by whatever my favorite number is, today my favorite number is 4, okay, then when I do that, what I create is still going to be true. 4 times 3 is 12, plus 4 times 7 is 28, is 4 times 10 is 40. That's true. That's still true, okay? If I use anything else, I will lose the truthfulness. So for instance, let's say I have my same true equation I'm talking about, that 3 plus 7 equals 10. Let's say that for whatever reason you wanted to manipulate that equation using addition. Well, you can't do that. Why can't you do that? Because what you create when you do that will not be true. So for instance, let's say that you want to just add 4 to every number. You're like, oh, okay, I'm going to manipulate this equation. I'm going to add 4 to every number. And in your mind, you think I'm allowed to do that. Well, look, you are not allowed to do that because 7 plus 11 is not 14. Okay? So you can only manipulate equations using multiplication because it's the only way that that equation remains true. So looking at my first example here on this slide, I do not have opposites, but I want to create opposites. All right. Actually, let's do the second one. Let's do the bottom one just to prove something to you here. I want to create opposites here. So I know I want to use multiplication. I always say, can I turn a 2x into a 5x using multiplication? Well, I mean, not with a whole number because I can't multiply 2 by a whole number and make it be 5. Can I turn a y into a 4y? Yes, I can. Now, I don't want to make that y be a 4y because that would be creating sames. I don't want sames, I want opposites. So if my top equation here has positive 4y, I want my bottom equation to have negative 4y. How do I turn a y into a negative 4y? I multiply everything in that equation by negative 4. Okay, so now what I have is, and I like to keep these things stacked, negative 4 times 5x is negative 20x. Negative 4 times y is negative 4y. Look, there's my opposites. Equals negative 4 times negative 7 is positive 28. And now I'm going to add these two equations together and do my process of elimination. Okay, so negative 20x plus 2x is negative 18x. Negative 4y plus 4y is eliminated. Equals 28 plus 8 is 36. I divide by negative 18. And I get that x equals negative 2. So my answer is negative 2, comma something. I now want to plug back into either of my equations. I could use any of these 3. 1, 2, 3. I could use any of them. Okay, I'm going to use this one right here because I just feel like it looks like it's the easiest. So I've got, I'll change colors so we can all stay organized here. I've got 5 times what I know x to be, which is now negative 2, plus y equals negative 7. So that means that negative 10 plus y equals negative 7. I add 10, and I get that y equals negative 3. Negative 2, comma, negative 3. That's my answer. It's where the two lines cross. That's the x, comma, y coordinate that makes both of those equations true. Okay, lastly. All right, look at the problem we run into here, okay? All right, well, let's look at number 1. All right, I don't have opposites. I want to make them. Can I turn a 4 into a 7 using multiplication? No. Can I turn a 2 into a 3 using multiplication? No. Okay, if you ever get to this, or you could use this trick all the time if you wanted to, then you're going to multiply both equations to make opposites, okay? And here's what you're going to do. You're going to multiply. Let's get opposites on my y's, okay? No, let's get opposites on my x's, okay? I'm going to multiply the top equation by the number that's in front of the bottom x, 7. I'm going to multiply the bottom equation by the number that's in front of the top x, 4. Okay, and always make these numbers out here to start with, make them positive. No matter what, make them positive, okay? Now, what I'm going to do is I'm going to do this. But before I do that, I want to double check to make sure that I made opposites and I didn't make sames. So 7 times 4x is 28x. 4 times 7x is also 28x. I just made sames. If I want to make opposites, I just make either of these two numbers negative. So I'm just going to make that negative 7. Okay? So now negative 7 times 4x is negative 28x. Negative 7 times positive 2y is negative 14y. Equals negative 7 times 14. 7 times 14 is negative 98. Down here, I'll use a different color just so we can stay organized here. 4 times 7x is 28x. Look at those opposites. That's what we wanted to do. 4 times negative 3 is negative 4 times negative 3y is negative 12y equals 4 times negative 8 is negative 32. Now I add these together. Negative 28x plus 28x is gone, eliminated. Negative 14y minus 12y is negative 26y equals negative 98 minus 32 is negative 130. Okay. When I divide that here, I've got that sorry, my mental math is really bad today. When I divide by negative 26, I've got that y equals 5. Now, okay, make sure that you put that in the y slot now. Don't get confused. Y is 5. Now, again, I can go back to any of the original equations to solve for x. I'm going to choose this one. Okay, so I've got 4x plus 2 times y, which I know to be 5, is equal to 14. Okay, so that's 4x plus 10 is equal to 14 minus 10. I've got that 4x equals 4 divided by 4, x equals 1. 1 comma 5. That's the x, y combination that makes both equations true. It's also where those two lines would cross if you put them on a graph. Okay? All right. That's it for the day. Make sure you just keep up watching the videos, keep up doing your homework. Yeah. Okay, I'll see you in class.